Hello, next video about the security of RSA, which relies on the privacy of D. So actually, just as a reminder, what is public is the value of N and E. What is public is also all the steps and the calculation that are needed to build and set up all the values. And we want to make sure that knowing N and E isn't sufficient to get the value of D. So actually, remember that D is calculated from the Bezout's identity or extended Euclid algorithm from two information, from E and from phi of N. That is, if you want to calculate D, you need the value of E, but it's public value, so you have it. But you also need the value of phi of N. And actually, what you know is N. So one knows N, and on the other end, if you want to calculate the value of D yourself, just imagine you fetch some public key N is sent by someone and you want to calculate D to try to get and act the messages. You need the value of phi of N. Also, you know that N is a product of two numbers. So actually, if you need phi of N, you also know how it's calculated. And actually, knowing phi of N is equivalent to know the values of P and Q. Once you get the values of P and Q, you know that phi of N is P minus 1 times Q minus 1. So knowing D is equivalent to knowing phi of N, because you know how to calculate the result. So if you have phi of N, you have the value of D. And knowing phi of N is equivalent to knowing P and Q. So the problem of knowing D is equivalent to the problem of knowing P and Q. And that's where things are very interesting, is that from a value of a number, one can easily tell if it's a prime number or not, but it's very, very, very difficult to get a decomposition of this number. Actually, if you choose P and Q and calculate N as P times Q, it's very easy. If you know only some number N, getting the prime factors of some number N is extremely difficult. So it all depends on the value of N, of course, but for practical implementation of RSA and in cryptography, it's extremely difficult if N is a huge number, so huge integer number with hundreds of digits in it. If N is a huge number, it's difficult if N is a product of two prime numbers. So actually, the more factors you have, the more it's easy to try to find them. Here we want actually the prime factors to be very hard and extremely difficult to get. So if N is a huge number, if N is a product of two prime numbers, and actually if those prime numbers are also huge. Actually, that's why, for practical sake, The prime numbers P and Q are two huge prime numbers, and N is their product. So if you have all those three conditions, actually, and still with the computers we have, the standard computers, you have choosing N as a product of two huge prime numbers makes it impossible even for a big computer to get the values of P and Q. It's named a very difficult problem. So that's why actually the privacy of the private key D is qualified as secure with regard to RSA. So it's impossible to get the value of the private key from the public key. That would be the conclusion of this example.